Bubbles are breaking through the calm surface of the Naples Sea again, rising in frantic bursts as if something is stirring beneath the bay right now. Scientists say these sudden boiling patches match the exact warning signs they feared most, and they now believe the sea is bubbling for a reason that could change everything. At first, it looked harmless, scattered bubbling patches rising through the otherwise calm Bay of Naples. Fishermen, who knew every shade and movement of the water, were the first to sense something was off. The bubbles weren't random. They formed in tight clusters, appearing and disappearing in minutes. The water around them shifted from clear blue to a cloudy green, then darkened as sediments stirred upward from below. Some boats reported faint but repetitive vibrations, like a soft engine rumble coming from the seabed itself.
This video takes a deep look at recent developments in the region, including more than 135 seismic events recorded in the past week alone. This activity indicates the movement of hot fluids beneath the surface, a classic sign of increased pressure in a magmatic system.
Local authorities initially brushed off the concerns as seasonal gas release or harmless biological activity, but early measurements taken by marine technicians painted a very different story. Carbon dioxide levels had spiked far above normal. Newly opened vents were releasing sulfur-rich gases at increasing rates. Temperature probes detected subtle but consistent warming along the seafloor. These weren't surface disturbances. They were the earliest symptoms of pressure rising deep beneath Naples.
It's a fumarole, the largest fumarole in the crater.
It's a very impressive feature. How would it have been formed?
It's a crack in the ground from which hot steam comes out.
Across Pozzuoli and parts of Naples, GPS stations began recording a pattern scientists hoped they wouldn't see again: rapid synchronized ground uplift. What had been slow, almost gentle brodiseism for months suddenly accelerated. Entire neighborhoods shifted upward by measurable centimeters in just a few weeks. Sidewalks developed fresh fractures. Pavements tilted slightly towards the sea. Residents reported doors no longer closing properly and windows jamming in their frames. These are small but unmistakable signs that the land itself was warping beneath their feet. Civil engineers conducted quick inspections and found subtle deformation spreading across older structures. In some areas, drainage paths reversed flow as the terrain tilted upward. Even the shoreline began creeping higher, exposing rocks and ancient steps that had long been underwater.
The risk is very high due to the high density of population here. Population within the caldera.
It's literally like living on a volcano.
Yes,
In a
within
volcano.
a volcano.
But
The uplift wasn't random. Satellite interferometry showed a broad dome forming right beneath the most active part of the Campi Flegrei system. Something underground was expanding, gas, magma, or both, and it was pushing the entire region upward like a slow, powerful breath. And with the ground rising faster, the signals beneath it grew more alarming.
More than just numbers, this data reflects the complex dynamics between magma, volcanic gases, and the Earth's crust beneath this densely populated city.
As the uplift continued, gas monitoring stations across Campi Flegrei lit up with readings the scientific teams had hoped to never see. Overnight, concentrations of carbon dioxide shot far above baseline. Helium-3, which is a rare isotope that only rises when magma approaches the surface, spiked sharply. Sulfur dioxide surged as well, a classic sign of superheated fluids forcing their way through fractures in the crust. These gases weren't drifting out slowly. They were venting with force, rising through cracks beneath the Pozzuoli, the Solfatara crater, and the Bay of Naples. Thermal cameras captured glowing plumes of vapor where there had been none just days earlier. Some vents emitted gas so concentrated that nearby vegetation turned yellow and brittle within hours. Researchers quickly compared the chemical signatures with historic data and found an unmistakable pattern. The mix matched conditions recorded before the 1538 Monte Nuovo eruption. That event reshaped the region, and the current readings were even stronger. Emergency teams installed new portable monitors around schools, ports, and residential blocks. The worry wasn't just rising levels, it was the rate of acceleration. And beneath the bay, the ocean itself began reacting to the pressure.
Field laboratories around the fumaroles also continuously measure changes in the concentration of volcanic gases such as CO2, SO2, and H2O. The chemical ratios between these gases provide important clues about the depth and heat source driving this activity.
Thermal drone flights over the Bay of Naples revealed something that immediately escalated the situation. Broad patches of the seafloor were warming rapidly. At first, the bright infrared signatures were limited to a small cluster near Pozzuoli. Within days, the hot zone widened into a sprawling network of glowing streaks beneath the waves. Underwater sensors confirmed the change. Temperatures had risen several degrees in a matter of weeks, far too fast to be caused by normal geothermal activity. The ocean above the vents shimmered like a pot being gently heated. Microvents multiplied, releasing constant streams of gas that made the sea appear to simmer. Some stretches produced enough bubbles to push small fishing boats sideways. Marine biologists documented fish fleeing the area, while divers reported visibility warping from the rising thermal plumes. These weren't isolated hotspots. The pattern pointed toward a massive body of pressurized heat moving beneath the crust, creeping upward and releasing energy through every weakness available. If the heat front continued expanding, it could destabilize the seabed itself, a precursor to violent hydrothermal explosions. Yet deeper signs suggested the true threat was only beginning to surface.
Red is all earthquakes. These are all earthquakes of the last week.
Yes.
We were there in March. There had been around 2,000 earthquakes in February alone.
As gas emissions and seafloor heating intensified, the ground responded with a new and unsettling rhythm. Clusters of shallow earthquakes began striking Naples, Pozzuoli, and the surrounding towns, sometimes dozens within a single hour. These weren't deep tectonic quakes. They were occurring just a few hundred meters below the surface, the exact depth where pressurized magma and superheated fluids force rock to crack. Residents reported windows rattling repeatedly through the night, while shop owners found fresh fractures running across their walls each morning. Seismologists reviewing the waveforms noticed a troubling progression. The quakes were becoming shallower, sharper, and migrating toward the area directly above the most active gas fields. This wasn't random shaking. It was the crust deforming under rising internal pressure. The last time Campi Flegrei produced this pattern, an eruption followed within days. Civil protection officials quietly raised monitoring levels, dispatching teams to inspect schools, bridges, and hospitals for structural stress. Every tremor signaled the same message. The system below was tightening like a clenched fist. And deeper underground, something even larger was beginning to awaken.
We know that under the ground there is a place, a volume, that is heated from fluids that come from below, from the magma chamber.
High-resolution radar and GPS data delivered the most alarming discovery yet. The deep magma chamber beneath Campi Flegrei was expanding, slowly at first, then with measurable acceleration. Instruments showed that molten rock was melting its way upward, softening the crust above and creating new pathways for gas and heat to rise. This was not the long, stable chamber scientists had monitored for decades. Its internal pressure had shifted, suggesting new magma injections from even deeper within the Earth. As the reservoir pushed upward, models indicated increasing stress on the brittle layers that had already weakened through years of uplift and seismic activity. Geophysicists compared current readings to historical records and found similarities to the buildup before past explosive phases, including the 1538 Monte Nuovo eruption. But this time, the affected area was far larger. Pressure simulations warned that the chamber was approaching a threshold where even minor shifts could trigger cascading failures in the crust. Researchers described the change with one phrase: a system entering a phase we hoped never to see again. And above this rising pressure, the sea delivered an even darker sign.
This is Lago d'Averno, Averno Lake.
And over to one side, in the distance there, looks like another volcano. Is that right?
Yes, that's Monte Nuovo. new mountain. It was formed in 1538 in 1 week.
Researchers begin cross-referencing modern readings with accounts from the months leading up to the 1538 birth of Monte Nuovo. What unsettles them is not a single anomaly, but a sequence repeating itself with unnerving precision. Gas emissions are climbing along the same coastal arcs where Renaissance fishermen once reported burning breaths rising from the sea. Shorelines are subtly shifting, matching the documented recession patterns that preceded the 1538 eruption by mere weeks. Even the rate of uplift across the caldera shows a familiar rhythm, slow pulses followed by abrupt accelerations, identical to the measurements inferred from old structural damage records and land deformation sketches preserved in archives. Each new dataset strengthens the parallel, pushing the team to consider a possibility they once viewed as distant, that the Campi Flegrei system may be entering a phase comparable to the one that produced Italy's most recent volcanic newborn. The echoes of history aren't distant, they're aligning in real time. Scientists brace as past patterns tighten their grip on the present landscape.
From Seth Doan in Italy, some notes from the underground.
The displays at this nerve center may rattle a few as they monitor the increasing volcanic activity around Naples, Italy.
As the scientific reports circulate through government channels, Italy's Civil Protection Agency escalates its posture without public fanfare. Internal bulletins upgrade the alert matrix, instructing regional offices to refresh evacuation models that haven't been touched in years. Sirens in coastal towns undergo unannounced tests, their sudden wails catching residents off guard. In schools, teachers quietly rehearse exit procedures, framing them as routine preparedness rather than emergency planning. Street-level notices begin appearing on notice boards. New assembly points, adjusted hazard zones, revised traffic flow maps for a potential mass departure. Beneath the quiet surface of the bay lies a network of vaults, vents, and pressurized chambers that behave very differently from land-based systems. Volcanologists warn that if pressure continues to build in the shallow hydrothermal zones, the first breakout may not come from a crater, but from under the water itself. A confined pulse of steam could flash to life, driving an underwater blast capable of lifting a column of scalding water, ash, and shattered sediment straight into the air. Models show that even a modest hydrothermal burst could send waves slamming into the nearest shoreline within minutes, while raining debris across ports, beaches, and densely packed neighborhoods. The danger isn't the scale of the explosion, it's the speed and proximity. With fishing boats, ferries, and waterfront homes sitting directly above unstable ground, the impact window would be brutally short. Experts stress that this scenario, while smaller than a magmatic eruption, remains one of the most immediate threats. Yet beneath every model lies a deeper concern scientists can't ignore. Across monitoring stations, the alarms aren't tied to one variable. They're tied to all of them moving together. Ground uplift continues in irregular surges, suggesting a pressurized system struggling to contain itself. Gas levels spike beyond historical baselines, with carbon dioxide and sulfur compounds rising through vents that once produced only faint emissions. Seismic swarms ripple beneath multiple sectors of the caldera, clustering around fault lines known for enabling rapid pressure transfer. And now, patches of seawater and crater floor pools are heating to levels that indicate boiling just meters below the surface. Individually, none of these signs guarantee an eruption. Combined, they form the exact convergence that researchers have long feared. A fragile crust suffering stress from multiple directions, vulnerable to even slight changes in pressure or temperature. The danger is not a dramatic trigger. It's a subtle shift that pushes the system across its threshold. For scientists tracking every tremor and bubble, the margin between stability and escalation is narrowing fast. And as data tightens the timeline, one final scenario takes shape. These shifts don't go unnoticed. Locals who have spent their lives on the caldera feel the tension rising beneath the official calm. Conversations in cafes revolve around the subtle but unmistakable signs. More patrol cars near monitoring stations, more helicopters scanning fumarole fields, more late-night meetings in municipal buildings with no explanations offered. The government isn't saying much, but its actions speak clearly. Something is changing, and every update signals shrinking margins for delay. And as precautions intensify, one question shadows the bay with growing weight. Could the bubbling sea off Naples signal a disaster the world isn't ready for? Let us know your thoughts in the comments.